Hey everyone, and welcome. Today, we are going to crack open one of the most essential and honestly most powerful parts of JavaScript, arrays. We're moving past just using them as simple storage bins. Instead, we're going to learn how to grab the real power tools to transform and manage lists of information like an absolute pro. Okay, let's get right into it. So just picture it for a second. You're deep in your code and you've got a list of something. Maybe it's student names, product prices, or high scores from a game. This happens all the time, right? It's a super common problem. The real question is, what's the smartest, cleanest way to actually handle all that data? Well, you could go the old school route and create a separate variable for every single item. But just look at that. It's clunky, it's a nightmare to manage, and it just doesn't scale at all. Now, the new way, the better way, is to use one single elegant container. And you guessed it, that container is the array. It just cleans everything up instantly. So what exactly is an array? At its heart, it's pretty simple. An array is just a special kind of variable that's built to hold more than one value. You got to think of it like a toolbox. Instead of having your hammers and screwdrivers scattered all over the garage, you've got them all neatly organized in one spot. This idea, this container, is the foundation for everything cool we're about to do. Okay, so before we bring out the heavy machinery, we've got to master the basics. How do we get items into and out of our array toolbox? Let's take a quick look at the two most fundamental methods for doing exactly that. First up is push. This is your go-to for adding a new item to your collection. It is incredibly simple. You just push a new value and it gets tacked right on to the very end of the array. It's simple, it's effective, and trust me, you are going to be using this one all the time. And on the flip side of push, we've got pop. Can you guess what it does? Yup, it removes the very last item from the array. Just think of it like taking the last tool you put into your box right back out again. Easy peasy. So here is the absolute crucial thing you need to remember about these two. Both of them directly change or mutate the original array. This is key. When you push or pop, you're not making a copy, you are modifying the list right where it is. They're your bread and butter tools for quick and simple list management. All right, basics are covered. Now for the really exciting part. Let's talk about the true power tools of array manipulation. I'm talking about the big three methods that are going to let you transform your data in some seriously incredible ways: map, filter, and reduce. Now this slide right here, this is basically your cheat sheet. Just look at how simple it makes things. You use map when you want to modify every item, and it gives you back a new array. You use filter when you want to select some of the items, and it also gives you back a new array. And then there's reduce, which is for smushing all the items together into just one single value. Keep this mental map, it'll help a ton. Let's start with map. Honestly, the best way to think about map is to picture a factory assembly line. It takes every single item from your original array, does something to it, maybe it paints it a new color or doubles its size, and then it places that newly transformed item onto a completely new conveyor belt, creating a brand new array. And here's a perfect real-world example. Let's say we start with an array of numbers, maybe 1, 2, 3, 4. We use map to do one simple thing to every single number, multiply it by 2. And what's the result? A brand new array, 2, 4, 6, 8. Now here's the crucial part. Our original array of numbers, it's left completely untouched. Next up, we've got filter. So if map is the assembly line, then filter is like your super strict quality control inspector. It looks at every single item coming down the line and asks a simple question. Hey, do you pass the test? If the answer is yes, that item gets to move into a new exclusive array. If the answer is no, well, it gets left behind. Well, let's see it in action. So we've got our array of numbers, but this time we want a new array that has only the even ones. Our filter condition acts like a bouncer at a club, asking each number, are you evenly divisible by 2? Only the numbers that can say yes get to go into our new, smaller filtered array. And again, the original array is safe and sound, totally unchanged. And finally, we have reduce. Now this one's a little different from the others. It's not about making a new list, it's about boiling everything down to a single answer. A great way to think about it is like a snowball rolling down a hill. It starts small, but it picks up every item in the array, one by one, combining them until you're just left with one big snowball, a single final value. The most classic use case for reduce is just finding the sum of a bunch of numbers. It works by keeping a running total, which we call an accumulator, and then for each item in the array, it adds it to that total. Now, that little 0 you see at the end of the code, that is super important.
That's our starting point. It's the initial value of our running total, and you should always provide it. It guarantees a predictable start and saves you from bugs if your array happens to be empty.
Okay, listen up. If you remember only one thing from this entire explainer, please let it be this. This is the golden rule. Unlike our basic tools push and pop, the power tools map and filter do not touch your original data. They are safe. They always give you a brand new array to work with. This idea is called immutability, and I promise you it will save you from so many headaches. It makes your code predictable, and that makes finding bugs 1,000 times easier. All right, theory is great, but let's see how these power tools actually work together to solve a real everyday problem. Everybody gets how a shopping cart works, right? So let's use our new skills to calculate a final bill. Okay, here's our game plan. We're going to start with a simple array of prices. First, we'll map over them to create a whole new array where an 18% tax has been added to each price. Next, we'll take that new array of taxed prices and filter it, keeping only the items that now cost more than $200. And finally, we'll reduce that filtered list down to get our single grand total. You see how each step just flows right into the next? This is called chaining, and it's how you write seriously clean, readable code. And after running our prices through that chain of operations, bam, we get our final number, $590. This is the total for all the items that, after tax was added, still cost over $200. And we did it all in just a few beautiful lines of code. So you've got the tools, and you've seen them in action. But you know, even the best woodworker can fall into a few common traps. So let's really quickly go over a few common mistakes to help you avoid them right from the start. Here are the top 3 slip-ups to watch out for. First, never use for each when what you actually want is a new array. For each is great for doing something for each item, like logging it to the console, but it doesn't give you anything back. If you need a new transformed array, you want map. Second, when you're using map or filter, if your function has curly braces, the curly braces things, you have to remember to write the return keyword. If you forget, you'll just get an array full of undefined, and that's a classic rookie mistake. And finally, like we said before, always give reduce an initial value. If you try to run it on an empty array without one, your program will crash. Simple as that. And there you have it. You've basically just upgraded from a simple toolbox to a full-on workshop of array power tools. The biggest takeaway here is that by chaining these methods, map, filter, reduce, you can write code that's not just powerful, but also way cleaner, more predictable, and a whole lot easier to debug. You're not just managing lists anymore. You're elegantly transforming entire streams of data. So the only question left is, with all this new power, what problem are you going to go solve first?